Okay, this is question 9, have a go. So this is obviously a differentiation question. Before we can differentiate, we really need to get this square root of x sorted out. So just rewrite it as x to the half. It makes it a lot easier to differentiate. So now we differentiate. Remember what we do here. We bring the power to the front and reduce the power by 1. So we get 2x here. Power to the front is halving minus 32, which is minus 16. Reduce the power by 1, half becomes minus a half. Now, at a stationary point, the gradient is 0, so we basically have dy dx equaling 0. So this now needs to be rearranged. So we add this to both sides, multiply through by root x, divide by 2, and so on, and we get x being 8 to the power of 2, 3. Cube root of 8 squared is 4. So we know that x is 4. So when x is 4, what is our y value? Because we've been asked to work out the coordinate of p. Well, we substitute this back into the original formula, not the differentiated formula, the original curve equation. So substituting 4 in, 4 squared minus 32, 4 to the half had 20, gives us this. So our y coordinate is minus 28, so the coordinates of our stationary point P are 4 minus 28. Now, to determine the nature of the stationary point, i.e. whether it's a maximum or a minimum, we need to do the second differential. So we differentiate this again, giving us this. And we know that x at the stationary point is 4, so we can see that when we substitute 4 in, we're actually going to get a positive value. We don't need to work it out, but we can just say because it's positive, in other words greater than 0, is therefore going to be a minimum value.